Hi, my name's Ivan, and today we're going to talk about reaction mechanisms. Right now, here in Everything You Need to Know. Now, I want you to imagine your favorite burger. Looks good, right? The toasted bun, the grilled patty, the perfect alignment, all of its perfection. But to arrive at your delicious end product, someone has to go on a certain processes. Someone has to grill the patty, toast the bun, put the cheese, and add your favorite toppings. Then, after those certain steps, you'll be able to eat your favorite burger. Now, in chemical reactions, we have something similar to this. Call it reaction mechanism. A reaction mechanism is a process or pathway by which a reaction occurs. We call each step in the reaction elementary steps. Before we move on to the actual reaction mechanisms, we must know first a concept that we call rate law expressions. For further information, let us welcome Toby.
Hello there, students who are desperate to get a passing grade in chemistry. My name is Toby, and I'm here to save your life. First, we must discuss rate law expressions. In a rate equation, we relate the reaction rate constant denoted by the letter K to the concentration of the reactants. This will result to the reaction rate denoted by the letter R. In this example formula, A plus B is equal to C plus D. These aren't actual elements, by the way. We write the rate equation as R is equal to the rate concentration constant times the concentration of A times the concentration of B. We only take the reactants of the chemical formula, aka the left side, for writing the rate law expression. So now you know the basics. Let us go back to my handsome friend, Ivan.
Thank you, Toby. Now, there are certain measures that help us evaluate proposed reaction mechanisms. Firstly, the elementary reaction equations add up to the overall reaction. Just like in burgers, one wrong ingredient won't make a delicious burger. Secondly, the rate law for the overall reaction is consistent with the rate of each elementary steps. After achieving the criteria, it is checked by the further experimental data by our experienced scientists. Criteria is paramount when it comes to evaluating reaction mechanisms. The overall reaction rate is determined at the rate of the steps up to the rate determining step. Now, in a reaction mechanism...
But Ivan, you haven't even discussed the rate determining step yet.
Oh, I haven't? Well... I was going to, but... you discuss it, right?
Okay. Before we discuss the rate determining step or any other confusing concepts that make you unsubscribe to this channel, I will give you a mechanism example. Nitrogen dioxide plus carbon monoxide is equal to nitrogen monoxide plus carbon dioxide. This is a reaction between nitrogen dioxide and carbon monoxide. Now you might think, oh, just add like a molecule of nitrogen dioxide to a carbon monoxide. But let me tell you, that's not how it works, you little But other than that, it's not that simple. It will have to go on a number of steps to arrive at the final product. Reactions that involve more than one elementary step are called complex reactions. A complex reaction will undergo certain steps, and in these certain steps, there may be a bond broken or a bond formed, just like in Lovekins. Now, the reaction between nitrogen dioxide and carbon monoxide doesn't take place in a single step. It's not an elementary reaction. Like I said before, it's a complex reaction. It takes two steps actually. It's a two-step reaction. These are the steps. These two steps occur at different speeds, and later we will discuss the importance of these speeds. But for now, we can see nitrogen dioxide on both sides on the equation. Two are in the reactants and one in the product side. NO3 also occurs on both sides of the reaction. These species are what we call reaction intermediates. They are produced in the reaction, but they will be later consumed, thus they won't appear in the overall reaction. So what we do, we cancel them out and we bring down the remaining, and we have the final equation. we can see truly that the elementary steps add up to the overall equation. So Ivan, we can now discuss the rate determining step.
Beside the steps adding up to the overall reaction, we consider the rates of completion within each step. The overall reaction rate is determined by the rate of the steps up to the slowest elementary step. The slowest step in a reaction mechanism is called the rate determining step. This step will determine the rate for the overall reaction. So, let us go back to our example. Now, the elementary step number 1 is the rate determining step because scientific evidence says that it is the slowest. But when we get to the rate law for this step, it won't correspond to the overall rate law expression. So, we can assume by this point that the reaction may take more than one step. So, we added all these steps and we cancel all the intermediates, then we finally drop them all down together to get the final overall equation.
But Ivan, what will happen if the fast step went first than the slow step?
Well, the reaction will...
So thank you, Ivan, for giving me this opportunity to discuss. Okay. Now to understand the situation, we need another example. Nitrogen monoxide plus oxide is equal to nitrogen dioxide. This is the proposed mechanism. By scientific data, we can see that the first step is faster than the second step. Now, we cannot assume that the slower step rate law is the overall rate law expression. This is because an intermediate, N2O2, is present within the rate law expression. But we know that it shouldn't be present because intermediates aren't present in the overall reaction. So what we're going to do isn't really easy, but if you follow my steps, you'll be able to master it in no time. And before you do that, hit the like and subscribe button down below. Now in the first step, we see that the reaction is in equilibrium. You can see that with the double arrow lines pointing towards the opposite ends. At equilibrium, the rate of the forward reaction will equal the rate of the reverse reaction. So with this, we can write this. Now with the laws of transposition, we can isolate the concentration of the intermediate, which is N2O2, so that we can come up with this formula. Now that we have the concentration of N2O2, or the intermediate, we can now substitute it to the rate determining step. This overall rate law, for your information, has been proven experimentally.
So, hopefully you now know the basics of reaction mechanisms. But before we end this video, let's have a little recap of what we have learned. Number 1, the reaction mechanism describes a sequence of elementary reaction that must occur to go from reactants to fragments. Number 2, reaction intermediates are formed in one step and then consumed in a later step of the reaction mechanism. Number 3, the slowest step in the reaction mechanism is called the rate determining or rate limiting step. Number 4, the overall reaction rate is determined by the rates of the steps up to the rate determining step. Number 5, the reaction with the slow initial step, the rate law will simply be determined with the stoichiometry of the reactants. Number 6, the rate law with a fast initial step, no intermediates can appear in the overall rate law. This is going to be the end of the video. I hope all of you have learned so much, and if you have any questions, comment down below. Don't forget to subscribe and hit that like button. Thank you for all watching and have a nice day.